Hello, welcome back. We're now up to 2.8. We're going to be solving some absolute value equations and inequalities today. And before we get going on that, let's talk a little bit about what a disjunction is. Disjunction means it's disjoint. We either have two parts. We're either here or we're here. So think disjunction or. We're kind of going in opposite directions here. So if we were to describe this, this is a compound inequality where x is going to be less than or equal to -3, or x is greater than 2. Remember, we use the or because you got to be one or the other. You can't be in both at the same time. All right, so we can just graph those. Now, the next one that we have is a conjunction. All right, a conjunction is where it's an and. Okay, in this case, x is greater than or equal to -3, and at the same time, it's less than 2. So we're joining together. Conjunction is what we have there. All right, so we can use these compound inequalities to either do conjunctions or disjunctions. That's going to lead us into the absolute values here. So once again, if we're going to graph these or solve them anyway, we have a disjunction. Just solve them each individually. Divide by 6, so we know y is less than or equal to -4. Here we just subtract 5. Y is greater than -2, so it's an or. Make sure you use an open circle on this one and a closed circle on that one. So it's going to be an or. We have two parts to it. Now we can do the same thing for a conjunction as well, is if we have that, just again, solve each one, divide by 2, so x is greater than or equal to -3. And now remember, if we divide by -1, we got to flip the sign, so x is going to be less than 4. So basically we're going to be in between -3 and 4. Make sure there's a closed circle at -3 and an open circle at 4. All right, so we have those conjunctions and disjunctions. That's going to lead us into the solving for absolute value. All right. Now, in absolute value, we're going to kind of get into this. Now, remember, absolute value is basically how far away from 0 are you? So the absolute value of 5, how far away are we, is 5. The absolute value of -5 is also 5. Absolute value is always positive. It just tells you how far away from 0 that you are. So, again, if we were to graph solutions to that, all right, this kind of leads us into the absolute value. If I asked you if the absolute value of x equals 3, that means our answers could either be -3 or 3. Okay, so that's always going to be an or if it's equal to. All right, now what if I asked you the absolute value of x, where is it less than? Less than 3. Well, all of the points where the distance is less than 3 is in between here. Remember, that's the conjunction. So this is where we would say the absolute value of x is less than 3 is when x is greater than -3 and less than 3 is what we're going to see there. So it's going to be in between. Well, what if we want to know when is the absolute value of x greater than 3? Well, those are all the points that are outside, beyond 3 and -3. So again, this becomes an or, which is a conjunction or disjunction. If the absolute value of x is greater than 3, that means x is greater than 3 or it's less than -3. And that kind of gets us into, okay, so how do you solve absolute values? And again, a key way of remembering this is that think greater is or. Less than, and, less than, and. So, all right, so let's go ahead and solve. I'll show you what to do. If we have an absolute value where it's equal to, it automatically becomes an or. Here's what you do. Make sure the absolute value is by itself. Once you do, just write it as you see it. -3 plus k equals 10. Or, here's what you do. Write -3 plus k, but now this time make it equal to its opposite. Because remember, whatever's inside that absolute value, if the absolute value is 10, it could either be 10 or it could be equal to -10. So now you just solve each of those. You add 3 to both sides. K is equal to 13. Or k is equal to -7, and it works for both of those. Okay, so that's how you solve the absolute values. Okay. Now, let's take a look at this. Another one, let's look at the inequality this time. All right, so now we make sure that the absolute value is by itself. Okay, once it is, then we just write it as we see it. We write -4q plus 2 is greater than or equal to 10. Now, since it's greater, we're going to say or. Greater is or. Or we say -4q plus 2. Now, here's what we do now. If it's an inequality, we're going to flip the inequality. We're going to make it less than or equal to the opposite, -10. That's what you do every single time. Set it up like that. Now just go ahead and solve. We get -4q is greater than or equal to 8. Q would then be less than or equal to -2. Remember, you have to flip the sign. Or, solve this. Negative 4q is less than or equal to negative 12. And then q would have to flip it, greater than or equal to 3. So if we were to graph that, here's negative 2, put a solid dot. Here's 3, put a solid dot. And let's see, less than negative 2 or greater than 3, there we are. There's our solution, just like that. That gets kind of tough. That's tough. All right, let's take a look at another one. This time where the absolute value isn't by itself right away. Ooh, okay, that makes it a little more challenging. All right, here we go. Now this time the absolute value isn't by itself. So since we're dividing by 2, what we're going to do is we're going to multiply both sides by 2. So we get the absolute value of x minus 5 is less than or equal to 8. Now we can break it up. We're going to write it just as we see it. X minus 5 is less than or equal to 8. Now since it's less than, that means it's an and. X minus 5, flip the sign, greater than or equal to negative 8. It's the same process every single time. So x is less than or equal to 13, and x is greater than or equal to negative 3. If we were to graph that, there's negative 3, there's 13, solid dots. This time it's and, so we're going in between. All right, so there we go. Solving absolute value equations and inequalities. Good stuff. Remember, greater is or, less than is and. Until next time, I'm Mr. Boone.